Find the volume under the graph of the function fxy equals to y over the region R, which the region is inside the top half circle of radius 2 centered at the origin. Okay, so if you have a circle of radius 2 centered at the origin, that's x squared plus y squared equals to 2 squared, right? And if you solve this for y, you get y equals to plus or minus square root of 4 minus x squared, but because we only want the top half, we just need the y to be positive. So this is the top half circle, imagined. And you are trying to integrate over this domain of the, and if you want to put dy inside, so you integrate y dy, you integrate from 0 to, well, because if you paint upwards, right? If you paint upwards, you start from y equals to 0 until this top half circle, which is square root of 4 minus x squared, and then y dy dx, and x goes from negative 2 to positive 2 because the radius is 2, so it goes from negative 2 to 2, and that's it. That's the integral that we want to do. If we want to calculate, let's actually do the calculation. Integral of y is 1/2 y squared. You plug in 4 minus x squared and 0 dx, and then when this is plugged in, the square root goes away and you get 1/2 4 minus x squared integral and negative 2 to 2 of dx. And now, because I mean, you could just integrate like this, but I'd like to use the fact that 4 and x squared, these are even functions, so you can just integrate from, if you're integrating an even function over a symmetric domain, you can just integrate from 0 to 2 and double the integral. And that's nice because 2 and 1/2 cancels, and you just have to integrate 4 minus x squared, which is 4x minus 1/3 x cubed, and you're plugging in 2 and 0. And when you plug in 2, you get 8 minus 1/3 times 8, which is 16 over 3. And when you plug in 0, it's just 0. So the answer is 16 over 3. Now, you could also do the same thing using the polar integration. If you use a polar coordinate system, the outside is r equals to 2, right? The circle of radius 2 centered at the origin are r equals to 2. And theta goes from 0 degrees to pi degrees, 180 degrees. So theta goes from 0 to pi. R, when you paint this radially, you go from 0 to r equals to 2. And you're integrating y, but y is r sine theta. And dy dx is r dr d theta. Okay. So if you do this, you get the same answer. Let's just try it. 0 pi, integrating r squared gives you 1/3 r cubed, right? And then you have sine theta. And then you have to plug in 2 and 0 d theta, so that's equal to 0 to pi. When 2 is plugged in, that's 8 over 3 sine theta d theta, and integral of sine is negative cosine, so 8 over 3 negative cosine theta, and you plug in pi and 0, and that's 8 over 3. If you plug in pi, that's negative 1. Cosine pi is negative 1, but you have negative of negative 1, so it's positive 1, minus negative of cosine of 0, but that's 1, right? So you end up with 2, so indeed you get 16 over 3. So that's an alternate way of calculating the same thing. Whichever way you think is better, you can use it. But often what happens is, in many cases, if you have a circular domain like this, you're going to find that the integral that you're given is impossible to do it this way, but only possible if you do it in the polar coordinate way. So it's very important that you know how to do it this way too.